Good afternoon, everyone, and thanks for joining us for today's webinar. I'm Brian Berger, Space News Editor-in-Chief and your host for this afternoon's event. Before we get started, I would like to remind attendees that you are on listen-only mode. We welcome questions, but please submit them via the Q&A feature at the bottom of your screen rather than the chat function. Over 1,000 of you signed up for today's webinar, so there's really no way we can get to everyone's questions, but I will do my best to make sure that our guests are asked a representative cross-section of the questions that you all submit. And go ahead and start submitting those as soon as they come to you, because we will be taking questions throughout the panel, not just at the end. So also please keep those questions short and to the point. That will help improve their chances of being seen. With that said, it's now my privilege to introduce Jason Kim from presenting sponsor Raytheon Intelligence and Space to help introduce today's topic, which is innovative space technology. Welcome, Jason.
Hey, thank you, Brian, and good afternoon, Colonel Felt and everybody on the webinar. Today, more than ever, are exciting times to be in space, as evidenced by the last weekend's launch of 2 U.S. astronauts from U.S. soil to the International Space Station. As corny as it sounds, that kind of excitement is with me every day at Raytheon Intelligence and Space. We play a role in delivering very cool, although lesser known, space technology that supports everything from national security to launches like the Crew Dragon spacecraft and the weather forecast we all rely on. The launch called attention to the desire for commercial aerospace to play a more significant role in national security, and that's important. But there's a fairly common misconception that fast innovation is exclusive to commercial industry. Traditional aerospace has tremendous talent, and you can see that in programs like IRIS-X, which we delivered in 29 months to AFRL. At the end of the day, it's a question of how do we provide the best technology to keep us safe and enable our servicemen and women to come back home. We have an obligation to provide a path to bring the best technologies to DoD programs, whether from traditional and commercial industry or a small startup or an idea on a napkin. And that's why this webinar is so important. I'm looking forward to hearing the role we can all play nurturing the right space technology for national security. Thank you, and back to Brian.
Thanks, Jason. So now I'm going to introduce Space News national security reporter, Sandra Erwin, who will be leading our conversation with today's guest. I'll let Sandra further introduce how today's webinar will proceed. Sandra?
Thank you, Brian. Good afternoon, everyone. Welcome. It's very nice to have you all with us this afternoon. I would like to introduce our first guest, Colonel Eric Felt. He's the director of the Air Force Research Lab's Space Vehicles Directorate. And I believe that a lot of our audience probably knows who you are and is familiar with the Space Vehicles Directorate, but maybe some people are not. So I was hoping maybe you can give us a brief description. What is the Space Vehicles Directorate? Tell us about what you guys do, and also maybe explain to us that you're now in the Air Force, but you're transitioning to the Space Force. So are you officially now under the Space Force, or will you be transitioning to the Space Force at some point in the future? Thank you and welcome.
Well, good afternoon, and thank you, Brian. Thank you, Sandra, and thank you also to Raytheon for sponsorship of this event. Super excited to be here because it's such a very exciting time in space and for AFRL. So those are great ways to start. So the Air Force Research Lab, of course, provides the science and technology to the Air Force. And now that we've stood up a Space Force, we are going to be providing the science and technology for the Space Force. And the way I think of that is like a pipeline. You know, we want to be the big idea pipeline of new technology that is going to be able to be brought into operations. And that starts with basic research, which we call like the 6-1 basic phenomenology, matures into what we call applied research, where you take the basic phenomenology and mature it into militarily useful capabilities, and then advanced development and prototyping, and eventually operational capabilities. So sometimes it takes a long time to get through the pipeline. And I don't really want General Raymond worried about that pipeline. So my job is to keep the pipeline full and keep the technologies that might be needed in the future maturing through this pipeline, so that when he needs them, as the Chief of Space Operations, he will have those coming out of the pipeline. So that's really how I view our AFRL role. Is we both, we turn the crank on the pipeline, and we try to think about things in the future that might be needed, and make sure that we are taking care of that stuff enough ahead of time. I really like the garden analogy. All right, I am a gardener. In the spring, I plant all kinds of different crops in my garden that I think might be needed in the fall, and some of those don't make it for one reason or another. Some of them I have to weed out along the way. But when we get to the fall, I hope I've got the right stuff in the garden ready for harvesting when it needs to be. So that's the mission of AFRL. And then here at the Space Vehicles Directorate, we do that for space vehicles, and we have a long history of maturing the components of satellites, and then demonstrating new capabilities on orbit with the integrated flight experiments, and then transitioning those into operational capabilities. So we are one of 10 directorates within AFRL, and we are the one that are focused on the satellite technology, essentially. One of the reasons then that this is such an exciting time in space and at AFRL is because of the stand-up of the Space Force, of course. And so we have come up with a construct, rather than pulling a piece of AFRL out. We're going to leave AFRL as one AFRL unit, so that we can still take advantage of all the synergies and the great capabilities that we have within AFRL, in terms of there are a lot of technologies that are used in both the air domain and the cyber domain. So think of materials, cyber, autonomy. Those are things that are useful across lots of different domains. So we still want those. So we're going to have one AFRL, but we're going to have that one AFRL now perform the science and technology function for 2 services. So what the Secretary Barrett directed in a memo in March was that we would take the space-focused parts of AFRL, and that ends up being about 700 billets and a certain amount of dollars over the FIDEP, and we would assign those to the Space Force, and then the Space Force is then going to assign those back to AFRL for execution, so that we will have a part of AFRL that's traceable to the Space Force and a part that's traceable to the Air Force, but we'll all work together on the science and technology challenges for our department of the Air Force. So that's the vision. It's been really exciting to work on that and kind of put that construct in place for our nation.
So we hear from the Space Force that they need advanced technology to stay ahead of China, other countries. There's adversaries that are threatening US space capabilities. So what are maybe 1 or 2 things that you can highlight that you're doing that could in the future maybe help the Space Force get that advantage?
Thank you. That is exactly what our mission is. We want to, again, make sure that the products in the garden are ready for the Space Force to harvest, and that they are always better than what our peer competitors have out there, so that we can make sure our space capabilities are there when our nation and our warfighter needs them the most. So I like to talk about 3 words, and they all happen to start with P. So it's really easy to remember those words. And we already talked about one of them, really. The first one is the pipeline, just having a robust pipeline. Both the Secretary and General Raymond have talked about how the 6th service, the Space Force, is going to be the most high-tech and the most dependent on technology of all of the services. So they recognize how important this pipeline is, and that we want to make sure we have a pipeline that's developing all of the needed things. Having that pipeline is an element of strategic deterrence all by itself. if you think about it, because your enemy then knows whatever they can do, you will be able to quickly respond because you have this robust science and technology pipeline. So that is a part of our mission every day that influences the strategic calculus of our adversaries in space. So that's the first P, is just keeping the pipeline going. That's the service I'm providing to the Space Force. The second P is partnerships. And here there's been an evolution of thinking that I think is really exciting. But there are all kinds of different partnerships. Now, we talked about the commercial crew launch on Saturday, which was super exciting. That was the culmination of perhaps the most successful public partnership of all time, I might say. And we have a state of the space industrial base report that'll be coming out in a couple of weeks. And one of the vignettes that you're going to see in there is how that public-private partnership saved NASA $20 to $30 billion. All right. So that is a powerful model that we would like to also use more of in the Department of Defense. I have already started doing that within AFRL on a much smaller scale, in terms of we've been having these what we call accelerators, where we get together with small companies and help them develop their min viable product and understand their customer base. It's really applying the lean startup methodology from industry into our development efforts within the government, which is a super powerful partnership with commercial industry that we're able to leverage. So another example of that is what we call the hybrid space architecture. And we're right now doing a lot of demos where not only do you have some dedicated government systems performing a certain mission, but whatever commercial capabilities out there, and there's a lot of it now because of the commercial space renaissance, you also are able to use that to meet your military needs. And in the hybrid architecture demo, for example, we've taken 266 commercial satellites that are able to basically perform imagery operations, weaved all those together for purposes of demonstrations and exercises, and shown how that can be added to our dedicated national satellites to create a great capability for our nation, a capability that's much more robust and resilient than just any one piece of that all by itself. So that's the second example of partnerships I wanted to be sure to highlight. And then the third P really stands for people. And all of this innovation depends on having people, entrepreneurs, innovators, scientists, and engineers. And so that is also a function of AFRL, to develop and nurture the people that we need to make sure that we can continue to stay ahead of our peers, our adversaries in space. And so in the State of the Space Industrial Base report, we're also going to highlight a few ideas there. So NASA, for example, says they need 10,000 more engineers just to get to the moon. Well, so there are things that our nation can do about that, and that AFRL can do about that. We propose the idea of a STEM ROTC, if you will, to help with undergraduate STEM education and providing more scholarships in return for service in a STEM field afterwards. Ideas like that. Within AFRL, we have a Space Scholars program where we try to engage and a University Nanosat program where we try to engage with the college age workforce to address the people issue. The Space Foundation also announced that they've got a Center for Innovation and Education that they are rolling out with a lot of ideas to get after this people element of stuff. So those are the three Ps that AFRL can bring to the Space Force to help with those innovation challenges and make sure that we can stay ahead of China and Russia.
Sandra, do you mind if I jump in with a quick follow-up on private-public partnerships?
Go ahead, Brian.
Sure. So, Colonel, you mentioned that NASA has achieved a lot of savings through its embrace of public-private partnerships, and perhaps the highest profile example of those efforts would be the Commercial Orbital Transportation Services Program that it started around 2005, 2006. It lived up to Mike Griffin's original vision this past weekend with the commercial crew flight. I take it that the Space Vehicles Directorate is not going to do something of that scale, but perhaps you could give us one example where you see effectively taking that page out of NASA's playbook.
Sure, Brian, that's a great, I do cite that example as the most dramatic example of success, I think, of the public-private partnerships, but there's so many small examples of success too. And one thing I've found within AFRL is that the great power of U.S. innovation and capitalism, it happens when the government can be a stable and reliable customer in the future. And what I mean by that is, let me give you a specific example in space domain awareness. Right now in space domain awareness, we have government telescopes, government satellites that go out and try to find where all of the objects in space are. And of course, we've got almost 30,000 objects in space now that we're trying to track. So that's a big job. But in addition, we have a lot of commercial capability from commercial telescopes and commercial space domain awareness capabilities that also get factored into painting the picture of what's going on in space. So what we would, one idea that we have talked about is that if we could set the standards for what the Space Force is going to need in the future for space domain awareness, for example, by laying out, in 3 years, we're going to buy 10,000 images of the geobelt per month, and we require this certain resolution. That's putting our value function out there. When we can put a value function like that out there, then private enterprise and the venture capitalists, they love that. They can go after that and they can innovate and deliver against that in the best possible way. So that's the kind of public-private partnership where the Space Force or the Air Force Research Lab just has to be the customer that's laying the value function out there. That kind of model can be extremely successful. So I gave you that one example in the space domain awareness. Generalizing that more broadly, AFRL, the Defense Innovation Unit, and the Space and Missile Systems Center are setting up a space commodities exchange. So this is really, the way to think about this is, we've got commodities exchange is in Chicago that have been trading wheat and other commodities for a long time. And the benefits of that are really, it opens up the financial engine to optimize both the price and getting the lowest possible price and the quality, where you establish certain quality standards for what you're going to need. The space domain awareness data that I talked about might be a great example of the kind of things that the Space Force could purchase through this space commodities exchange. So that's one of the innovative business models that we're working on as a way to, it's a kind of public-private partnership where we are the customer and we state what our value function is going to be in the future, and then we let commercial industry innovate to meet our standard and then buy things through this commodities exchange. That's the one of the experimental business models that we're working towards in the public-private partnership area.
Thank you.
Thanks, Colonel. Colonel Phelps, on that point of public-private partnerships, can we foresee maybe more cooperative projects between AFRL, space vehicles, and maybe the commercial LEO constellations? I know that you've had some interest in maybe trying some different approaches to communications for DoD. Is that something that potentially we're going to see in the future?
Yes, Sandra, that's a very exciting development. So the PLEO constellations, or proliferated LEO commercial innovation that's happening are super exciting, because that opens up all kinds of new things that we as the Space Force and as AFRL can demonstrate in space. So let me give you a specific example of a program that we call XVI. And XVI is neat because it's the Roman numerals for 16, and this is a Link 16 from space transponder. This is something we've never been able to do before because the place where we have our traditional communication satellites up in GEO is too far away. But if we have a proliferated LEO constellation, then what we could do is put one of these Link 16 transponders onto each of these LEO satellites, and you would basically have a Link 16 capability everywhere, all the time, all over the world. And that is a pretty powerful enabler to our warfighter. So we are flying a prototype called XVI of this transponder next March. And so we're going to put that up there and show that this thing that you've never been able to do from space before is now possible to do from space. And if that works out, then that's a great opportunity for us to partner with these commercial companies that are putting up some of the proliferated LEO constellations to provide that new military capability for our nation. Now, there are 30,000 Link 16 radios out there. So this is used from the ground troops to the airplanes to all kinds of military operations. It's the NATO standard. It would be super powerful to be able to have that kind of a transponder available everywhere, because the signals can't go through mountains. So it's a great capability to do from space. It's something we couldn't do from space before. And it's something that these proliferated LEO constellations might allow us to do from space. So that's one exciting example. The Air Force's ABMS program, Air Battle Management System, where we're essentially replacing the JSTARS and the AWACS airplanes, which, by the way, of course, would be very vulnerable flying over, China in a contested fight if we ever had to do that. Those are ideal missions to also move to low Earth orbit and leverage some of the commercial capabilities that are out there. So we see all kinds of new potential missions that we could be doing from space. And I'm working on the enabling technology to show how those new missions might be done.
And you have a solar energy experiment also lined up. Can you tell us a little bit on that one?
We do. We have a program called SPIDER, which is our Space Solar Power Incremental Demonstrations and Research program. And the vision for beaming power from space has been around for a long time. And in fact, I hope you direct the next question over there to my colleague at NRL, because he is super passionate about this topic. But on the SPIDER program, which we started last year, it's essentially a demonstration of on a very small scale of this technology, which would convert solar energy directly into RF energy, and then you could beam that wherever you need it. You could beam it to a forward operating base on the ground. You could beam it to a moving vehicle. You could beam it to a moving unmanned aerial vehicle. You could beam it to another satellite. So we call that power on demand. And that is also a very enabling logistical infrastructure capability that we might be able to offer to our nation. So I put that in the category of my pipeline of this could be really game changing in 10 years. So I'm going to start working on it now so that hopefully in the future, we will be able to have solar power beaming capability. So it is a super exciting program.
Yeah. So that gives me a segue to bring in Paul Jaffe from the Naval Research Laboratory. Welcome, Paul. Good to have you.
Glad to be here.
So, Paul, you overseeing an experiment that launched on May 16 on the X-37B space plane. And we have a short video that we can show now just to kind of give people an overview of your project, and then we can get into questions if that's okay with you.
By all means. Energy underlies pretty much everything we do, whether it is fighting a war or running an economy. Energy is really fundamental. So the ability to provide that in a way that is clean, constant, globally transmissible, and essentially unlimited, it's really powerful. RAM, the photovoltaic RF antenna module, is the result, the culmination really, of work that we've been doing at NRL for over 10 years. The experiment comes from a concept called solar power satellites, or space solar, in which the abundant and unimpeded sunlight in space, where it's brighter than anywhere on Earth, is collected and then sent to the Earth wherever it's needed.
This will be the first on-orbit test that we are aware of a space solar satellite. So the overall goal really is doing everything for the first time and proving that it works, and looking for areas that we can then improve upon this for future experiments and eventually the final system. One of the things that we would like to explore about this particular architecture is its thermal performance. It's kind of a tricky problem to have something that's in direct sunlight all the time, but maintain the temperature the electronics like to operate at. So in the future, this could potentially be a groundbreaking technology for really all of society. If everything works out, this could be a major baseload power source for how we power things in the future.
solar power satellites, the idea would be to provide energy anywhere in the world. So a really important component of these kind of satellites would be a device that can convert the sunlight into microwaves or some other form of electromagnetic energy that's suitable for sending to the Earth. And PRAM does this. It's a sunlight to microwave converter, and now it is time to test it actually in space and see how it performs. So we're really looking forward to the results of the experiment.
So, Paul, since the launch, what's been going on? When are we going to see results or hear more about results from this experiment?
So the word we've gotten so far is that the experiment was successfully powered up and is at the temperatures that we would expect and is generating the amount of power that we would expect. We have not received yet an actual dump of data. In part, that's just due to the processes in place with getting data from the X-37B. But we hope within the next month or so to actually get some data that's been collected and to have a chance to analyze that. And we would anticipate probably writing it up and being able to publish something probably later in the fall.
Okay. And do you have funding to maybe take this to the next phase? I mean, is this strictly a lab project, or do you foresee a future long-term with a sponsor or with a DoD organization?
We have been very fortunate to receive funding from a pretty wide range of sponsors. Definitely, even though the idea of solar power satellites has been around literally for decades, you could argue the 1800s or at least 1940, depending on what perspective you want to take. I would say we are still in the springtime of Colonel Felt's garden for space solar, where there's a lot of unanswered questions, and the experiment we're doing on the X-37 seeks to address some of those. I suspect if we can demonstrate that we're making progress, that we are achieving new levels of performance for certain metrics, it will be easier for us to have continued sponsorship. It is worth pointing out that this kind of stuff doesn't happen without that sponsorship, right? So we had contributions from the Office of Naval Research back over 10 years ago to start this project. We've had critical contributions from OSD, from the Operational Energy Capability Improvement Fund, and from many different groups in the Air Force. So this stuff doesn't happen by itself, especially when you're doing anything in space. If you're a principal investigator, it's critical to secure funding to make things happen.
Yeah, well, it sounds very interesting, and I see that a lot of questions are coming in from the audience. So Brian, you want to queue up some questions?
I'd be happy to, Sandra. Let's
Okay.
take a look at what we've got going on here. Got quite a few. Here's one that kind of stood out to me, and both Paul and the Colonel could address it if they like. That this really gets to space asset protection. What do you see as the biggest impact, current or future, from artificial intelligence and machine learning on space asset protection? Should we have the Colonel start with that one?
Sure, that's a great question. And that's a really good example of the kind of technology that is applicable across both the air domain and the space domain. So we have a lot of work in AFRL going on in machine learning and AI. Specifically in space, some of the ways that we're applying that right now are in the space domain awareness area, where we can have automated machine learning of how to process the telescope images to find the satellites, and especially then to find the satellites that are not doing what's expected in there. Those are prime right now today ways that we can apply machine learning and AI to try to find the interesting stuff in space amongst all the other data that is out there. The other area where we're really trying to apply more automation in general, and those are forms of automation, is in the actually flying of the satellites. So in the satellite command and control, right now today, we have space operators doing a lot of routine tasks that could and should and are being automated. And the reason we have to do that is so that they can focus on the space warfighting tasks and protecting and defending our assets when they need to be protected and defended. So that's a key enabler to our future ConOps of how we envision space happening. The commercial world is already automated a lot of those command and control tasks. So really what we're doing is implementing that kind of automation within the Air Force. And then the last example I'll give you is that we in AFRL are working on technologies to expand space domain awareness above the geobelt. So from the geobelt all the way to the moon and even a little bit beyond is what we call the XGEO or the cislunar area of operations. And as commercial people move there and our adversaries move there, that becomes an area where we need to know what's going on up there. So that is an area for space domain awareness that we need more capabilities in. So I am working on the technologies that will enable the Space Force to have better space domain awareness in the cislunar area. When you're that far away from the Earth, you depend more on automation in general, machine learning, AI, all of those techniques are super applicable both to defending your spacecraft that are up there and automating the processing of what's up there and just in general, all of the operations that are going on up there. So there's at least 3 examples of where we are applying machine learning and AI now and in the future.
Sandra, would you like me to bring it back to Paul for a question that's specific to his experiment?
Yes, of course. Paul,
okay.
Are you
so
ready?
We get a question from the audience, and the question is, if PRAM works, has it, then what are the next steps and where is this effort going in the long term? Are our adversaries interested and why?
Yeah, great question. And it really kind of opens up the aperture to a number of things. I should point out early on that PRAM is focused on a very specific architecture and a very specific subclass of that architecture for solar power satellites. So as I mentioned, the idea has been around for a really long time, and fundamentally, you're just collecting the sunlight in space and sending it to the Earth. But that can be done in many different ways, and there are literally dozens of different architectures for how to do it, many of which employ photovoltaics and microwave transmission, but others that employ different collection techniques and might use laser or millimeter wave transmission. So the experiment we're doing on the X-37B right now is for a particular architecture, and depending on how it turns out, it may cause us to iterate or revise the design for doing sunlight to microwave conversion for this particular type of architecture. The class is called sandwich module architectures. Some of the viewers might be familiar with John Mankins, author of the book, The Case for Space Solar Power, who has a concept he developed under NASA funding called SPS Alpha, which uses a sandwich approach. But there are many others, many that use laser power beaming and other ways. I would say at this point, we are early enough in the springtime that there are a number of different ways this could unfold or paths that we would decide to pursue based on the technology as it matures. And it's also worth emphasizing that the key technology for space solar that really is not mature enough yet is power beaming. And these are 2 different things. Power beaming is distinct from space solar because with power beaming, you can do all kinds of things in the near term that we can't do today. And without power beaming, there's no space solar in the future. As an example, we've been working at NRL and through various OSD funded efforts to advance power beaming technology, not just the microwave power beaming that is part of the experiment on X-37. Last year, we did a power beaming demo locally here to DC at the Naval Surface Warfare Center at Carter Rock that used lasers. And we're working on a number of different approaches for power beaming. One thing I'll mention that your viewers might be interested in is just a few months ago on the space station, astronaut Jessica Meir did a power beaming demonstration using just a small handheld element that you can make at home out of an LED and a Schottky diode to show how accessible power beaming is and that it's not this necessarily a mysterious new technology. And sorry, I'll add one more thing. The question also included reference to what are our foreign competitors doing.
Right.
And they have been active. So it depends on the country. The Japanese have been active in this area for a very long time, definitely at least decades. The Chinese, perhaps the last 15 years or so. My colleague, Namrata Goswami, has written a number of papers that go into some depth about the Chinese approach and their plans. Last year, they made an official announcement through CAS, the Chinese Academy of Space Technology, talking a little bit about their goals, both near term and far term. Their aim is to develop a megawatt level capability in the 2030s and a gigawatt capability in the 2050s. The things they're doing today to work towards that are developing the power beaming technology, and they've actually set up a research facility that's focused solely on this area.
Thank you.
And I would offer that the SPIDER program builds on some of that early NRL work. And what we've discovered in the SPIDER program is that while the idea has been around for a long time, it wasn't technically possible until recently. And so now we actually see no insurmountable technical barriers to actually making this technology work. I mean, you've got the solar cells as mature as they need to be, the large structures in space, and these are very large structures that'll probably have to be assembled in space, so that requires a logistics infrastructure. The metrology to keep the knowledge of where each element of the panel is, so that you can beam the power exactly where you need it to be. All of those technologies are super critical and are now at the point where they're mature enough to go on to this next phase of the demo. So that's where the next phase of the SPIDER program is to put a 2 square meter panel up into LEO, and then actually beam a tiny bit of power to the ground to prove the basic technologies. And then, from there, we'll move into the summer and the fall of the power of maturing power beaming, so that it'll be ready to be harvested. But I love what NRL has done there. And by the way, they're a partner with us on SPIDER in terms of building the Rectenna, which is the receiver system for this power.
So Colonel Felt, these projects take a lot of planning, preparation, funding, getting the resources lined up. Can you maybe walk us through how do projects get selected at AFRL? Now that there's a Space Force, are they going to have an input into what experiments get funded? Kind of tell us a little bit of the mystery of how things get selected.
Those are great questions. And I have been spending a lot of time ever since January, when we in December 20th, when we found out we were going to have a Space Force and it was stood up. And then in early January, I'm never going to forget the great week we had in Colorado Springs, where we got pulled together to architect the Space Force. And the direction we got from General Raymond was so inspiring. It was, hey, you've got a blank sheet of paper. Everything you thought was wrong with the Air Force and not optimized for space, go fix that. Make our service the envy of all the other services. And so that was a really inspiring vision to dig in and figure out, well, okay, so in my lane in the road in science and technology, how should this process work? And how should I make sure I take the inputs from the current programs, which we call the tech pull side of things, as well as the tech push side of things, where when I see new technologies that are now available and feasible, such as power beaming, how do I tech push those things into military capabilities? And both sides of that, the opportunity to architect that from the ground up and make sure that we have robust processes to do that, so exciting. So I'm never going to forget that great week in January. Now, what we've ended up with is a process that goes through and methodically reviews the tech needs with our partners out at the Space Force and they're responsible for the requirements in space. And then at the Space and Missile Systems Center, which is going to be the Space Systems Command, they are the program offices that actually build the requirements. Through those three partners, we develop the tech needs, and then we develop plans for how to get after those tech needs. And that process is what we have been doing for a long time. And what we decided about that part of it was that's actually working pretty well. We are going to continue that as a best practice in the new Space Force days for the pull side of things. And then on the push side of things, what we've done is partner with the Air Force Warfighting Integration Center, and that is a new office, new a couple years ago in the Pentagon, that stood up to re-architect the Air Force capabilities and make sure that we were building in the Air Force the right capabilities to respond to the national defense strategy and to the pivot towards China as our primary competitor. So by partnering with AFWIC, we came up with a way to evaluate new ideas and to figure out what their potential military utility was through modeling and simulation and analysis and expert judgment. And so the way I make decisions now, and at the end of June, I'm about to make some decisions within AFRL on where to put our future money. But the way I make those decisions now is based on a cost versus utility curve. All right. So we want to find the highest ROI projects, the highest bang for the buck that you can get. And the utility function that we're using is really, moving the needle on a conflict with China in 2030 to 2035. So that is the utility function that we think we're getting out of the National Defense Strategy, that I want to be sure I'm planting those technologies into the garden in the spring, so that when and if we need those in the fall, those will be available. By planting those in the spring, that also deters the probability that we'll ever need those need to actually use those technologies in a war that extends to space in the fall. So that's the utility function that I'm using, and then we have cost estimators that go in and look at these things and how expensive they are to deliver to the warfighter. And then there's still the partnership with the Space Force headquarters and with the program offices to make sure that when I'm done developing the technologies, they actually transition into programs and capabilities at the end. So there's a pull and a push side of this.
So what are some things that you're going to be funding for next year?
Well, the couple of, we have taken, I have teams working on, in the fall, I narrowed it down to 10 potential projects. We're now down to about 4 after doing some customer discovery and stuff. And what I've had those folks do, this was a really neat idea that some of my people had. They said, hey, we have these accelerators where we're putting small companies through this process of customer discovery and the lean startup methodology. Why don't we do that internally? And so I thought that was a fantastic idea. So we took these 4 teams that were the finalists from for this next flight experiment project, and we put them through an internal accelerator. And they're almost at the end of their internal accelerator, where they have, as part of this, they go talk to 100 people about what they need in this particular tech area or this particular warfighting domain, from the users to the SPOs to the Army to all the potential customers. That's the customer discovery part of things. And then they really scrub their project to be like, okay, rather than just, building one thing that's going to cost $500 million, are there some little incremental steps along the way where I could prove out the basic technology and gain further customer advocacy and partnerships along the way? That's the min viable product part of things. So I put them through this internal accelerator. They're almost at the end of it. It's been super interesting to me. A couple of things that I've noticed about that. Not ready to announce we don't know who the winner is yet. I'm not quite ready to announce even who the finalists are, but I'll tell you a few things. There's the best payoff is coming from things that we're not currently doing in space today. So I already gave a couple examples of that from XVI, something we didn't used to be able to do in space, now is possible in terms of Link 16. From Air Battle Management System, where things that we used to do on the AWACS and JSTARS can and should and need to be done from space, is another example of that. In this accelerator, we are looking at different non-traditional orbits. I've got one team that's looking down at what we call VLEO, which is very low Earth orbit. This is like where you have to be thrusting all the time just to keep your satellite in orbit, in 200 to 300 kilometer area. We didn't used to be able to fly there very much because we didn't have as good in-space propulsion as we do today. Now we've got better technology for in-space propulsion, opens up this new orbital regime for potential use. And so this team's been going and discover, well, what can we do in VLEO? And then I've got another team that I already mentioned, the cislunar or the above geo region for space domain awareness. That stuff you can't do very well from the surface of the Earth. So you need to have some satellites out there to do this space domain awareness mission. And it's very dependent on the logistics infrastructure of how you get out there and support it in terms of communications and position, navigation, and timing. How do you know where you are? How do you need to refuel? How all of those logistical issues are really important as you get further out into the lunar regime. So I got another team that's looking out there. Okay, how are we going to do this space domain awareness problem out near the moon? So it's been really interesting to put the teams through this internal accelerator, and that's the process that we're going through. And we will announce the winner of that soon, next month probably. Fascinating.
Thank you for that. Brian, you got any more questions?
There are, Sandra, and I also have a poll I'd like to submit to the audience, and it ties into some of those questions that have come across about what the 5 areas are that the Colonel has referred to. I think I have a poll question here that kind of reflects those. I'm going to go ahead and share with everybody. Can you guys all see this on your screens?
I can see it, Brian, and that is a great
Excellent.
question. I can't wait to get people's input on this.
Yes, this is gonna decide your spending priorities for the next few years. This is going to be official. This is going to be it. You know, since we're entirely in a virtual era right now, we can just skip with congressional hearings and budget reviews. We'll just use the SpaceNews webinar poll to set funding priorities. Does that sound fair to everybody?
Sounds like a great data point as input to me.
Good answer. Good answer. So once this starts slowing down, we'll end the poll. Are you guys seeing the results live? I'm seeing them where I'm sitting. Okay, voting is slowing down. Let's see what happens when I click. It's still coming in. We'll leave that going. We can continue talking as long as, but Sandra, do you see me at this point or do you see just the poll?
Just the poll.
Just the poll. Well, let's end it. Take a look at what it says. Just give it a couple more seconds. People are hitting it now. We'll get to 3 to 10. I hate to stop voting while it's still going on, but at the same time, you know, it's got to end. All right. Share results. So anything jump out to anybody here among our panelists or Sandra, anybody up there? We'll see where things are falling. We see what the winner was. SSA.
So space situational awareness, which we now call space domain awareness, gets after that area above geo that I was talking about that is now opened up as a region of interest for us to make sure we know what's going on up there. So I'm not surprised by that part of it. You know, I've got a great program going on in PNT already. It's called Navigation Technology Satellite 3, which is a super well-chosen name because NTS 1 and 2 flew in the 70s and led to GPS, and then NTS 3, I like to call it the China-beating PNT satellite, and it's really getting after, you know, modern waveforms, more modern ways of doing the position, navigation, and timing mission, so that those capabilities will be there when we need them the most in a high-end conflict, in the presence of jamming, et cetera. So point being, we already have a lot going on in PNT, I would assess. So super interesting results. I thank you, audience. This is great input to have.
Excellent. I have a question too, Sandra, if now would be an appropriate time to ask it.
Yes, absolutely.
So we got a question about the ongoing COVID pandemic and the impacts it might have on emerging space businesses. The question gets to, what do you see as the role of AFRL in fostering the commercial space renaissance? I want to return this question to your gardening analogy. And that would be to ask you, you know, you have the will, I suppose, to help and to ensure that this continues to prosper. But do you have the water rights and irrigation equipment ready to at least play a part in keeping venture space from becoming a dust bowl? You know, and then just even more specifically, is there anything you've already done so far this spring and anything that you intend to do yet this year to help keep those crops watered?
Brian, that's a fantastic question, and I love how you've embraced the garden analogy. That's awesome. That's awesome. So, COVID has affected our industrial base, especially on the new space side. So I would, you know, those folks were relying on, you know, venture capital investment, and that's really 80% of the tech investment that's going on right now. So there's a big impact when venture capital dries up, bank loans dry up. You know, we were concerned and are still concerned about that. So the kinds of things that we have tried to do to help, first of all, we had a number of efforts in the pipeline for contract awards, et cetera. And when it was helpful, we pulled those award dates earlier and really focused on some particular companies needed those awards and needed them sooner than others. And we tried to be responsive to that. And so that's one little way that we tried to help out, you know, with with cash flow, in particular on the new space side of things. The other way that I think is super important gets back to this this public-private partnership idea, or in particular, the way I'm interpreting that is sending the right demand signal for what we want to buy from commercial in the future, so that they can then let the markets respond to that and meet that need in the best way possible. If we do that right, then that will enable some successful exits from these venture capital and investments that have happened on the new space side. And when you get those successful exits, because they identified their market well and they met their market need, and now they're ready to move to become public companies or be bought out by somebody else. Once you have those exits, then that will reopen the spigot for venture capital investment into space, COVID or no COVID. So those are the couple of the things that in AFRL, I feel like we can have an influence on to get through this time, this desert time. The real concern, is that, I mean, if OneWeb already went bankrupt. We've had a couple of other examples, and what we don't, of course, our nightmare scenario is that key space technology will get bought at fire sale prices by, foreign competitors. And so that is of great concern to us. And so we don't want that to happen. Our future, our continued lead in innovation in this area depends on that robust commercial, especially this new space side of things, but the old space is nothing to slouch at either in terms of the great innovative capability they have over there. So our future depends on that. So I just think it does require a very proactive view, and that each of us, act within our realm to be aware of what's going on and to try to take care of ensuring we are all working towards this end state where we can maintain a robust commercial space entrepreneurial culture in the US. That is the key to our success, as a continued success as a nation in space.
Thank you. Brian, you have any more questions?
I can hand it back to you if you like. At some point before we break here, I see that some folks did, I guess you have to press the polling button at the bottom of your screen in order to see the poll. So before we end here today, I will put that screen back up for anybody who wants to screenshot it. And then of course we'll finish with a fun poll towards the end. But I'm happy to ask more audience questions, or Sandra, you can take back over.
I wanted to ask a follow-up question to Colonel Felt on your last point about the private sector and the impact of COVID. This report that's coming out in a couple of weeks, will you be recommending anything specific? I mean, what are some things that that you believe that maybe are not being done that could be done in a different way, working with the industrial base?
Sure. Well, I mean, first of all, let me just talk about how the report came to be. So we had a State of the Space Industrial Base conference that was really sponsored by New Space New Mexico, and pulled together groups on a Zoom call, much like this, in early May, to just see where we were. And it was really both a near term kind of, how do we get through COVID, midterm, how do we, send the right demand signal to industry to enable them to be successful, and then far term, how do we identify, the space solar power and the next big ideas in space to really keep the innovation pipeline going. And we split up into 6 little sub working groups, and what was amazing to me was how effective that meeting was, being in this virtual format. It was kind of the first time I'd done a virtual conference, and we got better. We got a higher. We got all the participants we wanted because they didn't have to travel to the conference. It was easier for them to participate via Zoom, and we still were able to have great discussions and come out with great recommendations. So we did put our top 6 recommendations into the press release that came out right after the conference. And what we're doing now is polishing the report that, again, that's going to come out in a week or two on, the further details of what that's going to happen. But the big takeaways to me were, first of all, this is not an AFRL issue to solve. This isn't, not a Space Force issue or a DoD issue to solve, but, this is really got to look across the whole of government to look at how we're going to get after this, because we're all interdependent on each other. I mean, I need that commercial sector to be successful. I need, the Department of Education and the National Science Foundation to put these scholarships out there to make sure my workforce is there when I need it. I need the financial sector to, have the Space Commodities Exchange and the successful exits from the venture capital and the investments to make sure that we get more of that going. So it's all tied together in a really interdependent but powerful way. I mean, those are the kind of the secret weapons that we have to make us successful, and they're not so secret, but they are hard to replicate. One of my favorite sayings, and I learned this at the conference, was, we must not become China to beat China. All right. So let's take the things that we're really good at and what we know how to do in this country, and let's double down on those. And no doubt in my mind, we can be successful. But so I got the six highest level recommendations we already put out there, and they're all centered around, this is a whole of government thing, and let's all strategize on how to do this together. So the next time we have a State of the Space Industrial Base conference, and we will need to keep having these, we know some additional people we need to invite beyond just the DoD and NASA, and which were the main participants this time around. But it's a great conference, and we look forward to getting the report out.
Great, thank you. So we're down to like 5 minutes left, so I'd like to maybe get a few more audience questions if we have them.
We do. We have a lot of audience questions. Here's kind of a broad one, but I guess I'd invite the Colonel to keep his answer as succinct as possible so we can get a few more of these in. Continuing the garden analogy, what are the top 5 weeds, in this case challenges, that you anticipate as your directorate evolves?
So one of the challenges that I've had is to really get us pivoted to the new way of looking at things. So the new national defense strategy was a big pivot for the Department of Defense. It was like, okay, we're not worried about Iraq and Afghanistan are not our top problems anymore. Fighting terrorism, not our top problems. We need to pivot towards having capabilities to deter China and Russia. Well, that's a big deal. That's a big change for all of us in the Department of Defense. And so one of my biggest challenges is to implement that direction down into AFRL. For example, I'm not so interested now in doing some of the projects we were doing before that are little small incremental improvements in efficiency. I'm now looking for the big game changers, the stuff that's going to be have a great squash or other product produced in the fall that the Space Force is going to really be able to use for effective purposes. So to pivot from the incremental to the game changers, and it's always hard to discontinue projects, but you always have limited resources. So that's been the biggest challenge. And some of those weeds that I've had to pull out are really the more incremental improvements rather than the game changing stuff. So we really are going after the game changing things.
Thank you. A lot of questions here about kind of cyber resiliency, incorporating legacy systems into some of your kind of advanced concepts. In the interest of time, I would just invite you to kind of speak to those two topics, what you're doing to kind of foster the best technologies, the military will need in those, well, I guess involving legacy and also making sure that you incorporate cyber resiliency, or the military can incorporate cyber resiliency into some of these advanced concepts you have. Could you speak to that?
Sure. So we have the world's best space capabilities up there right now. So there's no, even though we have a vision of a hybrid space architecture in the future that includes those plus commercial capabilities, and I have focused a lot on, how do we shape the commercial capabilities side of things. That doesn't change the need to continuously improve the government dedicated side of the architecture too. And so we actually do still have a lot of efforts going on there, a lot of close partnerships with like the GPS SPO out in Los Angeles, et cetera, on how to improve the we call it the legacy architecture, but it's a great legacy on which we're building. And so I think that's all part of the hybrid architecture, just improving every element of the hybrid architecture. Cyber is a huge deal. And so our thought, we are vulnerable in every domain to cyber threats. And we have a number of technologies in AFRL that are kind of domain agnostic to get after, root of trust, zero trust architectures, leveraging all of the tools that we have on the ground and in the IP-based systems to improve the cyber resiliency of our space-based systems. All of those are factored into our cyber strategy, and I see a huge demand signal for even more in that area. That's another area where we're kind of limited by the people and the talent that are available. So I am planting a lot of seeds to get after the cyber threats, and some of them are going to work out and some of them might not, but it's a really important area that we get after that, and we recognize that, and we'll see what the fruits look like in the fall on the cyber side of things.
I have a final poll for the audience, and this kind of gets to something we had chatted about a little bit during our prep session. Realizing very quickly from these webinars that we're doing that there's a lot of Space Force fans among the Space Force, and here I'm talking about the Netflix show that just debuted recently. So I wanted to ask our audience to vote on an AFRL related storyline for season 2 of the show. So let me put these up. No guarantee that these are under consideration, but here you go. For those who might not be able to see it, when a mysterious blackout pulls the plug on General Naird's backyard beach bash, an NRL space solar power experiment aboard X-37B saves the day. The Beach Boys' Brian Wilson guest stars. Okay, we got some votes for that. After POTUS calls for the cancellation of AFRL, mistaking it for the hirsute cat-eating alien ALF of 80s sitcom fame, Space Force's flaky flack mounts a social media offensive to save the lab. It does not go well. And finally, when a wayward OneWeb satellite threatens to collide with the ISS during the film of a Tom Cruise movie, Space Force quietly commandeers the orbital outpost Roll-Out Solar Array to flick the satellite out of harm's way. Or so they assume. We didn't talk about Rosa, but if you can picture one of those party favors you blow on and it pops out at you, that's kind of what Rosa does. So give you a few minutes or a few more seconds to vote on that, and we'll see what people like. I wish there was a way that I could display the other poll results side by side. But Sandra, do you want to kind of bring us home as we let this poll continue, and then we'll kind of just close out on the results and.
Yes, I know we're at the end of our hour, so I wanted to thank our guests, Colonel Eric Felt, thank you very much. Paul Jaffe, also would like to thank Jason Kim from Raytheon. Really appreciate your time and thank you for this interesting discussion. I know there's a lot more to talk about, but we'll have to leave it for another time.
Definitely. And here are those results. I'm not seeing graphs on all of them, but it looks like, if I'm not mistaken, the winner was the wayward OneWeb satellite threatens to collide with the ISS while Tom Cruise is filming a movie there. I did not list intentionally a guest star for that episode. I suppose it could be Tom Cruise, but that might be a budget issue. So let me get one more poll result up there just for folks to see it so they can screenshot it if they missed it last time. Stop sharing that one. Go over to the other one. Okay. So this is your chance, folks, to screenshot this for what it's worth, non-scientific, right, opt-in survey. That's enough with that. I'm gonna take it down. I wanna thank everybody for joining us today, especially our guest and our sponsor for today's webinar, Raytheon. With that, I'm going to say farewell, and we hope to see you back for our next webinar. Thank you, everybody.
Thank you, Brian and Sandra. Fantastic.
Thank you.